All right, the next type of functional group that has a carbonyl in it are the esters. Esters are the product of a carboxylic acid reacting with an alcohol. They form the basis of many fats and oils and the pleasant flavors and odors of fruits. All right, so the ester, we have the carbonyl. All right, if you have R groups there, you've got ketone. If you've got an H and an R group, you've got an aldehyde. If you've got two H's, it would be an aldehyde as well, formaldehyde. If you've got an R group, carbonyl, and the OH, that's the carboxylic acid. Now the ester is similar to the carboxylic acid in that you have the carbonyl with an R group and an oxygen, but you have another R group, which I could call R prime to say that it's different than the other one, or it could be the same. But essentially, this is your ester right here. So the simplest ester is this, which is methyl ethanoate. Essentially, we've got a methyl group here, and that's where this methyl comes from. And then since there's two carbons right there, it's ethanoate or methyl acetate. Because again, if we go back to the common names, when there's two carbons right there with the carbonyl, it's acetic. Acetone has that's acetone. Acetic acid is this. Acetaldehyde, which I don't know if I covered that with the aldehydes, is that right there. So they all have that acetic part to it, which is where the acetate comes from. Esterification is the reaction that actually makes an ester from a carboxylic acid. And so what you can see right down here is we have ethanoic acid, which would also be called acetic acid, reacting with methanol or methyl alcohol. And what we get out of that is this methyl portion over there and the ethane part right there because there's two carbons, so methyl ethanoate. It also makes, as a result, water. It has to be done in the presence of acid, and you can heat it up. Example 4. The ester that smells like plums can be synthesized from methanoic acid. And so I'm just going to draw that. And 1-butanol. All right, so we've got 4 carbons, 2, 3, 4, and the alcohol is going to be at the 1 position. So if I were to fix this a little, I'm going to make the alcohol right here just because it makes it easier to see all this. And I'm going to change this to blue. All right, so now there's 1, 2 carbons, 3, and 4. All right, this is 1-butanol. In black, I've got the methanoic acid. All right. Write the balanced chemical equation for the formation of this ester. All right, so what's going to be made here is this. All right, and so the name of that, we'll get into naming in a second, but the name of this would be butyl methanoate. All right, so naming esters. There are 2 parts to each ester's name. The first part comes from the alcohol that would react with the carboxylic acid from part 2, and that means right here. If I go back into the reaction 2 slides ago where we had acetic acid, which would be more formally known as ethanoic acid. Again, this comes from vinegar. I find it funny that acetic acid literally means acid because acetic is Greek for acid. When that reacts with methanol, it makes the compound here. All right, so step 1, there are 2 parts to each ester's name. The first part comes from the alcohol, since it comes from methanol, which is really derived from a methane group, which we call methyl. When it's a group, you put that first, and then secondly, the second part of the name comes from the carboxylate ion. If we were to ionize this, you'd get the ion here, which would be called the ethanoate ion. And so the name of this molecule right here is called methyl ethanoate. The molecule on the left here, since basically what you do is you look at the portion that is attached to the oxygen first. So right there we have an ethyl group, and then on the left side of it that's bonded directly to the carbonyl, you also have an ethyl group. Okay, so the name of this molecule is really ethyl, blue from the portion on the right, and then, and I know it's tough to see, but ethanoate from the portion on the left. Here we go. I'll highlight it in black and put ethanoate in green here. All right. And then for the middle molecule, you've got a methyl, and then you have a propyl group, so you get methyl propanoate. For the molecule on the right here, you have an ethyl. Let me put here, I'll write it in methyl and propyl. And then over here, on the left of that molecule on the right, you've got that group there, which is a benzyl group. And so it's ethyl benzoate. All right, what's on here is the production of aspirin, which actually comes from the esterification of a salicylic acid, which comes from willow bark, the inner bark of a willow tree, and acetic acid. People have actually been chewing the bark of willow trees apparently since ancient times, like before Christ and everything, into ancient Greece, because they knew that it would actually relieve pain, which is pretty cool. But if you react that with acetic acid, you get aspirin. And so the name of aspirin in its IUPAC form, if you look at it closely, is actually not going to be proper. We have acetyl salicylic acid. The acetyl portion, mind you, is supposed to, the front part of the name, the first part, usually comes from the alcohol. But the alcohol that is reacting is this. And that would be attacking that carbonyl, that carboxylic acid, which would be kicking this off to form water. So really, the name of this molecule should be salicylic. And then what we have is the carboxylic acid, or the carboxylate portion, which has got 2 carbons. And so really it should be salicylic ethanoate. Now if you look on Wikipedia, the page for aspirin or acetyl salicylic acid, you will not see salicylic ethanoate as an alternative name for it. So they just named it wrong, and they probably thought that what happened was this right here, that they probably thought that hydroxyl group reacted initially right here and kicked this off to form water, and so they, I mean, it worked and whatever, and so maybe they thought they formed a different molecule which would actually look like this. All right, let me right there is what it would look like, and that should be acetyl salicylic acid according to the proper naming of esters, but this actually is a different type of thing that would actually be an anhydride, but we won't get into that. So suffice it to say that the naming of esters doesn't always work. Now obviously in your test I'm not going to give you something that wouldn't work, so you won't have to worry about that. Example 5 here, write the IUPAC name for the following ester which gives the odor and flavor of grapes. So on the right we have 1 and 2 carbons, so this comes from ethanol, so this will be ethyl. And then on the left side we've got 1, 2, 3, 4, 5, 6, 7 carbons, so it'll be ethyl heptanoate. There's some more types of esters here and their flavor / odor. Propyl ethanoate gives the flavor for pears. Pentyl ethanoate is bananas. Octyl ethanoate, oranges. Ethyl butanoate, pineapples. And pentyl butanoate, apricots. So if you haven't figured it out yet, esters might be the best chemical because they give all of these amazing flavors to us. All right, in this section we covered the carboxyl group, carboxylate ion, carboxylate salts essentially, and I kind of went over that, or I skipped over it in a sense because it doesn't really matter, but carboxylic acids, esters, and esterification.